All right, before I start this video off, I just kind of wanted to say a few things. I am looking for a new service technician to work with our team, to add to my team, okay? But here's the caveat. I'm looking for a service technician with experience that lives in the Inland Empire, okay? Our office is out of Riverside. We mainly work in the Inland Empire and Orange County. Okay, but I need someone right now in the Inland Empire to add to our team. We're obviously, got lots of work going on, and I've just been thinking about it for a long time. I wanted to do this before the whole virus thing, but I needed to kind of get through it. As we're coming out of it, I'm ready to do this. Okay, now I am looking for an experienced service technician that is capable and already works or knows how to work in the restaurant side of things. Okay. I do restaurant refrigeration and air conditioning. I work on air conditioning, refrigerators, ice machines, walk-in coolers, prep tables. Okay, I do not do any hot side work. I don't work on fryers. I don't work on soup wells, any of that kind of stuff. Okay, just the refrigeration and air conditioning side. Like I said, an experienced technician right now. Now, as far as the people that aren't experienced and cannot hit the ground running at this point, I will be willing to train soon, but not yet. Okay, so the resumes that I'm looking for right now is for the experienced service technician that has experience in the restaurant side of things. Okay, if you have that experience and you're interested in working with me, you guys have seen from my videos, I'm probably an asshole. Okay, but I mean, we treat everybody right. I just expect things to get done right. All right. I really, really care passionately about the customer taking care of them, making sure that we're fair and honest with them. Okay. We're not a sales driven company. We're not there to push crap down people's throats that they don't need. We're there to fix their equipment, to do it right, to get it working, to be honest, and to make good money. That's what we're here for. Okay. So if you are that service technician and you live in the Inland Empire of Southern California and you're interested in coming to work for me, I'd like you to send me a resume to hvacrvideos@gmail.com. Again, I realize that there's a lot of people that are going to want to apply that don't have the experience. Guys, I'm not looking for you right now, but I will be soon. Okay, but right now, I'm just looking for that experienced service technician that lives in the Inland Empire that wants to come work with us. I'd love for you to join our team. So send me an email to hvacrvideos@gmail.com.
Ooh, listen to that, man. That does not sound good. Yeah, I'm gonna change that right now. And you know what else I'm gonna do? Is we're gonna fix these covers too. So I'm gonna power this guy down and fix this.
This video is brought to you by Sportland. Quality, integrity, and tradition.
Today we have a call on a kitchen AC that is not working properly. This is not one of my normal locations. I've done some work to help them out in the past before here. Anyways, long story, but so we're gonna dive into this guy. They did send me a video of what was going on and whether or not it all makes sense, but they had a transformer that was tripping like a secondary circuit breaker. So we open it up, and we've got a number 10 on the M17 board. Looks like we have a full call for cooling, G, Y1, Y2, and occupied signal. Now the customer told me they came up here thinking they could fix it. You see the trip transformer, but they had told me they thought maybe the fuses, they were just kind of reaching. So they had pulled the fuses out. So I have the fuses. I'm gonna go ahead and put those back in. And it looks like, I believe this is the secondary transformer is tripped. So we're gonna dive into it. All right, I threw the fuses back in and power's off to the unit. I've confirmed it. I'm just doing a visual inspection and this unit is a mess. I mean, little things like, look, there's a relay missing. It's a combustion air, so I'm assuming this thing has no heat. All the wires are just there. It just seems like a mess. And it's weird though too, because look up here. Look at this seam right here. You see that seam? It's like, and there's a bunch of screws and I don't know, it looks weird. It looks like someone was wrenching on it. It's got, like they grabbed it with channel locks. Like what the heck are they doing? So this is the return air section and like look at the insulation's just falling down. These cheesy filters in there are ridiculous, but look at how much stuff we see. We just see wires shorted. This thing is greasy as all get up. It's nasty. But, oh, that's funny, look at that. It's like a mound of grease that came out of that hole. So obviously they have a greasy kitchen. Filters are dirty. Look in here, same thing. Like, look at the top of the unit. Someone's been, I don't know why they would have pulled the top off of one of these. There's really no reason to, unless someone didn't know what they were doing. But this thing's a mess. I mean, drain pan's plugged up, full of water. That's a large amount of water in that drain pan. Oh, it's gonna be interesting. Look at how many extra belts there is. Like I said, this isn't my store, but we're just looking for any obvious signs of a short or potential short causing the transformer to trip. Things just sitting there rubbing on the bottom. This thing's a mess. Belts are somewhat snug, but like, look at the top of this unit. I mean, people have done some silly things in here. Oh, look at that. I mean, you know, that's a mess. I don't know what is going on here. Why someone would pull the top off this unit. These Lennox units, there's really no reason to pull the top off. But look at that. That's crazy. All right, well, I'm looking right here because this is where the hinge from the door goes, right here. I'm looking to see if we have a short right there, maybe? No, it doesn't look like it. But that's interesting. I mean, could have some, no, I don't see any cut wires, but man, this unit is just beat down for real. Whoever's taking care of this place is not doing a good job. Get down in here. I'm just looking for any wires. See all sorts of things. I think there might be a refrigerant leak too, because there's oil all over that 3/8 copper line. Coming down in here. Right, well, we gotta figure out what's tripping that transformer. So we're gonna start troubleshooting. Looks like an economizer jack. Whether or not that's actually even hooked up, I don't know. So I started off by removing the ground wire from the transformer, because they ground them out oftentimes on the common side. Now there could be other ground sources on the common side of the low voltage transformer, but we're gonna start there. Now I also verified that I have a good ground to the panel. In multiple places I verified we've got a good ground. So then we're just gonna go from, there's a terminal strip up here. It goes pink and then gray on the bottom. Gray is the common side of the transformer, low voltage. So we should have no short to ground on the pink. That's the high voltage side. And we've got a direct short to ground right now on this low voltage transformer. So we need to trace out that problem. We have a direct short to ground on the positive power side of the low voltage transformer. And it's gonna be starting on any one of these 5 wires, and we can trace it out from there to figure out where the short to ground is. All right, I have confirmed that this transformer is labeled T18 and this transformer is labeled T1. Our problem lies more than likely in T18. If we come over to the schematic, we can see right here, this is the electrical symbol for a transformer. So this is one transformer. Notice that it says T1. And we come over here, here's another transformer and it says T18. So they have one ladder diagram right here showing all the different low voltage things that are going on in here. So what we need to do is we need to follow T18. So if we follow it down, it's going to this ladder right here, and each one of these dots is a connection point. So relay K159, that is a symbol for a relay. So K159 is what we need to look at. I've marked them all. K149 we need to look at. K150, P118. You notice right here there's no black dot. That means that it's not making a connection. That's kind of like a jump over. So this is controlled by the other transformer. So we ignore. Look right here, we have the black dot. So K114 and then K3. So we need to investigate those relays and the wiring going to them to see if we can find where our potential short could be. All right, so what I'm doing is, this is a mess, by the way. There's wires going everywhere. But I started at K159 because that's the first relay that I came across. And I checked across the coil to make sure that we had good resistance, and we did. The next one is K149, which is the outdoor fan relay. So I'm just testing the relays first. And what I'm going to do is go ahead and test to make sure that my relay across the coil has resistance. 44 ohms, and that was about what K159 had. Also, it's kind of difficult to see, but if you look on these wiring, there's labels to make sure that they're going to the right place too, so you can actually verify. This one's a little faint, but this one says K149A, and if you look on this relay, it says A. So this one goes here. K149B is going to be the common. All right, and I'm going to go ahead and disconnect the commons to each relay because we still do have, I think, a grounded wire on the commons. So we're going to disconnect the common and leave them unhooked, if I can do it carefully, so that way we can still trace this problem out. All right, I couldn't find the source. I still have some things unhooked, so I powered the unit back up, and we're going to see what happens when we get a call. We've got no call, power's applied, and we did not trip the transformer yet. So we're just going to monitor and see what happens, you know, when we get a call, that kind of stuff. So, all right, a couple things. Talking with the manager, again, this isn't my location, so I'm trying to make sense of some weird stuff. First off, I don't like wires just hanging down like this, you know. But this transformer, it just doesn't look right. So I start investigating a little bit more, and I find out that it's only a 50 VA. From the factory, they have a 70 VA in here. So I'm gonna start there, okay? Whether or not there's a lot of wiggle room in the factory's transformer, I don't know, but we're gonna start by putting back the proper transformer in there. The next thing I'm noticing is that when I apply voltage to this contactor, power's not applied to the unit right now, but when I apply voltage, I've got 24 volts and this contactor's not pulling in, but it's ohming out good. So I don't know what's going on here. This is a little interesting. So we're gonna start by putting the factory transformer, or the equivalent. I'm gonna put a 75 VA in there. And then we're gonna clean up this mess in here and then go from there. All right, I got the new transformer in there. The wires are tucked up, you know, nice and neat, plugged in where they should be. I'm gonna clean up some of this too, but next thing I'm doing is I happen to have one of these relays, so I'm gonna go ahead and wire this up so we don't have a bunch of wires just dangling in here. And if you look in the bottom of the unit, especially after other people played with it, you'll start finding all the screws. Like here's all the screws, the extra screw for that guy. People just drop stuff for the most part, so you can just look down and see there's another one too. People just drop everything. So we're just putting the unit back to factory specs, and then we'll continue our troubleshooting. Okay, so we have a call for G. My compressor, there goes my compressor contactor. It just called in, pulled in, okay. So now we have a compressor contactor. We're gonna watch this guy because I don't like doing what I did in that I just started changing things without finding exactly what was wrong. But the problem is that I'm undoing another company's mess. And so it's like, where do you start? Sometimes you just gotta pick a point and start. So I started by putting the relay back in and getting rid of all the dangling wires. I started by putting the proper transformer in, and then we're gonna continue to troubleshoot. So we're gonna keep watching it, watch all the stages, come on and see what happens. I have got all stages calling right now. K2, which is not on that transformer, is chattering or buzzing. It doesn't have voltage drop across it, but that one doesn't affect that transformer, but we're probably gonna change that contactor though. I'll make sure that we got a good 24 volts coming in. So far I'm not seeing anything that would cause the transformer to trip, but I will say that the condenser fan motors aren't cycling correct. And I think that they've messed up the wiring. So I gotta go through here and figure out what's going where. Yeah, see, this one's labeled for K150, which is condenser fan motor 4. So they're not staging the condenser fan motors correctly too, and that could cause a problem. See, when you walk up to things like this, it can be a cluster F trying to figure out what other people have done. So sometimes you really got to look at the big picture kind of a thing and try to evaluate and undo their mess before you start troubleshooting. So what I noticed was when just one compressor was running, my condenser fan motors for the first stage weren't running. And you know, I have them labeled here according to this, and it didn't make sense. So the first stage is the top half of the front of the condenser, so theoretically we should have been running these two. One of them cycling on pressure, one of them running, so I got to go through. But like I said, this one's labeled K150, and it's on K68. K150 is number 4. So I got to figure out which ones are which and label them. All right, I swapped them. So these two bottom relays, the condenser fan motors, were flip-flopped, which could cause high head pressure issues later on down the line. So I verified all the condenser fan motors are wired correctly and controlled by the respective relays. Ooh, listen to that, man. That does not sound good. Yeah, I'm gonna change that right now. And you know what else I'm gonna do? Is we're gonna fix these covers too. So I'm gonna power this guy down and fix this. So I replaced this contactor because it was buzzing, chattering, making not working correctly, and it had the right voltage. And then I reversed the covers to untrigger myself. One thing I will say, man, this indoor blower assembly is really loud. Yeah, maybe that belt could use a tightening. I'm talking to this customer. They're gonna have to let me come in and do some PM work because this is disgusting, these drains. I'm on overtime today because it's a Saturday, so this is literally just get them out of a bind and then we'll come back and clean it up. We're back up and running again, all stages. You can see I can actually hear myself think and it's not buzzing my face off anymore. You can only do so much when it comes to zip tying things in here because you don't want to put too much strain and stuff. The only thing I did, it doesn't look the greatest, but I got these from laying on the top of this box, just zip tied up, and then just kind of zip tied. It's kind of weird if you look at the control voltage. They brought it in through, so I'm not going to redo that right now. That's kind of a loop. That's silly. Really don't want to be running that control voltage with the high voltage either, but we'll deal with that another time. Just kind of went through here, zip tied a few things up, mainly in here, a couple zip ties, got it nice and tightened up. Yeah, just still watching the unit operate, seems to be good so far. Came over here to this economizer actuator and I actually tested it. The actuator's not working. We had a signal from the unit telling it to open, it was maxed out and the actuator's not moving. So I went ahead and unplugged it for now, just to eliminate it as an overload or anything. And we're gonna go in here, we're gonna secure this sensor wire. I'm assuming that's the enthalpy sensor probably, and I don't think it's running. So we're just going through and just, fine tuning a few things, making sure we're not, don't have any other shorts. And again, I'm gonna talk the customer into letting me come back and clean this unit up, hopefully. According to Measure Quick, our head pressure's a little bit low, our suction pressure's a little bit high. Let's go through the numbers here and see what we got. Superheat's on the money, subcooling's just a little bit on the high side, but I'm gonna be honest with you, I'm not too worried about that subcooling. Liquid line, yeah, it seems to be coming and going. The approach is really low. This is a Lennox unit, and we don't have a very good TD right now. We only have a 14-degree temperature split on this guy. Okay, so the first stage doesn't look horrible to me. We'll pull up Measure Quick and see what it has to say. I'm just gonna go ahead and clear that out. Low load on the evaporator, I agree, because it's really cool in the kitchen. Potential duct leakage, maybe. System may be overcharged. That's, that approach being really low, it's a possibility. Okay, so we're gonna go ahead and gauge up on the second stage and see what that one looks like. An important thing to remember on these Lennox units when you're using Measure Quick is it's important to draw out which condenser is which. You will get a different air temperature in here as opposed to out here because let's say the sun is beating down on the condenser. So you can, you gotta make sure that you get your air probes put appropriately in the right place. So this one, because I'm dealing with the second stage now, well, the other thing too is you wanna make sure all the condenser fan motors are running. So the first stage was on this side. Second stage, we're gonna go ahead and grab in here because the second stage is the top half of that guy. And then the third stage is going to be a mix of the bottom. So, all right. So let's, first off, I'm on the second stage. We have high suction pressure, high head pressure. Our approach temperature is lower than what the factory wants it to be. I mean, we're close. The factory wants about 8 degrees approach on the second stage. Let's go ahead and scroll back here. Subcooling about 14 degrees. I'm not too worried about that. Lennox doesn't publish subcooling, but I tend to see in the 14-15 degree range. So it's not horrible. I'm leaning towards on all of these guys that this unit needs just a darn good PM. I'm leaning towards dirty condenser, Possible overcharge, but I don't think so. We'll see. We're gonna gauge up on the 3rd stage now. Okay, we're on the 3rd stage. We're a little low on our approach temperature. It's kind of ranging back and forth, but the factory one's 9 degrees approach on the 3rd stage. Subcooling's a little bit higher. Oops. That's why we have a fancy cover on our tablet. It's showing my head pressure being a little high, suction pressure being high. But overall, everything is running. We still don't have a great temperature split across the unit. We're still low on that. Our BTU output is low, but we need to clean this unit up. This unit needs a thorough condenser coil cleaning. Also, what's kind of weird is these should all be the same condenser fan motors, and they're all amping differently. One of them's amping, I can't remember if it's a lot higher or a lot lower. So we could have, it's possible, I need to investigate it when we come back. They may have not put the right condenser fan motor in there, and I'll show you those numbers real quick. So the condenser fan motors are actually rated at 2.4 amps. So actually that's not bad, 2 amps. But there's one of them in here that's really weird. 1.79, that's really low. That's condenser fan motor number 1. 2 amps. And I think I got one more left. The other one's running 2 amps too. I tested it. So we got one running 1.76, which is kind of weird. That is really weird because the one running the low amps is actually this one. The unit just satisfied, shut down, but they're all the same motors. It's rated to run 2.4 and this one's running 1.76, but all the other ones are running 2 amps. It's kind of bizarre. Huh. Well, we'll talk to him again. We're gonna have to come back, so. I am back. The problem persisted. So I left on a Saturday. It ran all day Saturday, no problems, and then took a dump again on a Sunday. This is the problem that the manager had told me about originally that I didn't see when I was here, is the transformer keeps tripping. So I reset it right now and it trips again. Further investigation's kind of telling me a few things. So again, this isn't my location I mentioned, and another company has been servicing this. And I remember I showed you guys in the video that like, hey, someone had taken the top off the unit. I don't know why. Stuff was just, you know, wires were undone. It looked like someone had been troubleshooting this. Now I had asked the manager, hey, do you have an invoice from the previous company? And they said, no, they can't find it. I told them that would really help me, but I'm looking at a few things, right? And notice that people have written codes, 10, 49, 47. And notice that we come over here and someone has marked 10, 14. And then if you come in here, that's actually my error code is 10 because it's just a low voltage short. And what happens is when I reset it, well, it's not gonna do, oh yeah, it's gonna do it right now. But it just trips again. So we're gonna have to get in here. Oh no, I have to reset the board to get it to trip again. So if you hold this down, power it down, and then watch, it'll trip right away when it starts. There it goes, it already tripped. So I got to trace this down. This obviously has a problem that I think the previous company was trying to diagnose this same issue. And all that I know the manager had told me was they changed a thermostat. That's all that I know they have done. And now remember, when I came out here, I found they had the wrong transformer. I found that there was a relay missing. I cleaned that up and I couldn't get it to duplicate the problem again. 24 volt shorts can be difficult, whether or not there's so many different variables in here. I mean, it could be in the circuit board, it could be in a lot of things. So I'm gonna get to troubleshooting and see if I can show you guys what I figure out. I disconnected all the thermostat wires, and what I'm gonna do, I reset the transformer. It doesn't trip by itself, which tells me it has something to do with the call for cooling, who knows. So we're gonna put the unit into test mode and see if we can run it in test mode. So we're gonna go shift, unit test. We're gonna go C11 for full cooling. C11, full cooling. We're gonna see what happens. There it goes, it trips. Okay, So that tells me it has nothing to do with the thermostat. Okay, so we're using some troubleshooting techniques. It has absolutely nothing to do with the thermostat, so we can trace it from there. Now it has something to do with the unit wiring. Let's do another test here. And what we're gonna do is go ahead and take it out of test. And we're gonna go shift, unit test. And we're gonna reset it. Okay. And then we're gonna test each individual component, because you can do it that way too. So we're gonna test each individual component and see if we can figure out where the problem is by testing each component. Understanding everything about this unit can be a little difficult. I've traced kind of traced my problem to the indoor blower contactor. At least that's where I kind of associate it with. And what I did was I come over here and I start noticing some markings. Terminal board 24. I found terminal board 24. That's right here, and it's literally just a junction point. The wire comes out of the board, goes into that, comes back up, goes into the board. But I start looking at the connectors that are also connected to this, and then I start thinking what else is going on with the indoor blower motor, and I start thinking about some limit switches for the heating section, okay? And then I remembered that, hey, I had seen a problem with limit switches. So I come over here and I saw this the other day, and I don't know why I didn't jump on this earlier. This limit switch looks like junk, and I went ahead and disconnected all the wires from it, and it no longer trips. So this is one of those ones that was really difficult to find, because low voltage shorts are always difficult on these units. So I disconnected it, and let's see if we can duplicate our problem. So we can put it into test mode now. I'm just testing the blower. Decimal pops up, indoor blower turns on, and we're not tripping the transformer. So I'm gonna go ahead and hook that limit switch back up and see what happens. And let's see if it trips again. So we're gonna go ahead and... Nope. See, it's an intermittent short, and it's somewhere in that limit switch. It's intermittent. So let's take a screwdriver, see if we can get it to trip by tapping on it. That's why I couldn't find the short the other day. No, it's not going to do it, but it's intermittent. Comes and goes. So we're going to disconnect that limit switch and then get them some new ones. What a pain, man. Oof. All right, I went ahead and disconnected this one for now, and I climbed back here to disconnect this one, and I'm going to take you back there and see what I see. It's one of these things that just drives you nuts. Look at the wire right here. Intermittently shorting. Ugh, drive you nuts, man. All right, I'm just gonna disconnect everything. These wires are numbered, so I'll know how to rewire them. We're gonna get 2 new limit switches. I'm hoping that this is it. Again, this is an intermittent problem, so what a pain, man. Grr, right? We started back up, and it recognized that we have a primary heat limit, which is the one that we bypassed. I'm gonna turn off all the gas valves so the heater won't turn on, and we'll actually turn off the main gas too, and then that way we can order the limit switches. But I'm going to test the unit to make sure that everything works right now. One of the things that you got to remember in the beginning of this video, I don't know if I caught it on camera or not, but I said something about those limit switches. I said they looked like crap, I remember. And you got to trust your gut. So it was an intermittent problem, right? Because I was like, where's this short at? I started to try to chest to ground, and I really wasn't picking it up. It was weird. I was getting, and it makes sense, it's intermittent now, okay? Because I got a short, but then I didn't get a short. It was just tripping me out. And that's where I started by putting the unit back together, putting the correct transformer in there, replacing that relay with the wires, and then I just inspected everything, and I couldn't get it to trip again, okay? I didn't think twice about the writing from the previous company. I didn't even look at that, you know? And same thing here, I didn't even look at that. But then once I started to investigate, I see that the previous technician was using the same logic that I had, and they were like, you know, jumping through that stuff. And I should have addressed those limit switches when I saw it the first time. because I might not be here today. It's not my fault. This is still billable time because, especially because I'm coming in on another company. I have to fix what they did before I could, because it just happens that way. Okay, now it'd be one thing if I was the technician to disconnect all that stuff and then leave it that way. Yeah, I probably would, kick back on some labor or something like that because, yeah, whatever. But no, I'm not kicking back on any labor on this one. That's the way I'm rolling because I had to put this unit back in operation from the factory essentially before I could go any further. And I explained that to the manager. In fact, it was written on my invoice too. So this is all billable time, but I am going to order those relays, and that'll give me some time to make sure that we don't have any more intermittent short issues. There certainly is a lot wrong with this unit. Plugged up filters, economizer messed up. This unit's beat down, but I'm pretty sure that we got it this time because I was a little unsure when I had left on Saturday, just changing the transformer and the relay, and I couldn't duplicate the problem. And that's why I covered my butt and explained to the customer that I had to start over. And because usually when I do something like that, I want to see the problem because I don't want to make a guess or assume, because sometimes this happens and it makes you second guess yourself. Okay, so that's where we're at. We're going to order that limit switch, and then I'm going to go down and turn Y1 and Y2 on at the thermostat to make sure that we get a full call and no trips. All right, we have a full call for cooling. We are staggering between 60 and 50 as an error code, and that's primary limit switch 1, primary limit switch 2, which I have them bypassed. And that's another thing too. I was thinking, why would a limit switch when it's in the cooling mode trip the safety or trip the transformer? Well, with exactly the point being that it shows the error message, it's always providing power to that. Like right now, we're not in heating mode, but the board is recognizing that I disconnected those limit switches. So it's always applying power to those limit switches, and it was intermittently tripping it basically. And again, it makes more sense too, because if I go to this terminal board right here, it says W2 on that terminal board. And the limit switch that actually, the further one, was the one where the wire was disconnected, and that's W2. So it has something to do with this section. It's probably powered by this transformer, that whole thing. So again, I'm thinking in my head, like, why would it trip, the cooling cycle and all that stuff? But that's more than likely, it makes sense to me, that's why. So yeah, we're gonna order those limit switches and then go from there. Came back out today to replace these bad limit switches that were all shorted. Got them both installed, that one right there, and then the other one back in there. The wires are secured now, so they're not rubbing on anything, nice and high. So yeah, we're gonna start it up. All right, I'm starting the unit back up. No error codes displayed. What I am gonna do though is reset the error code. So we're gonna go to recall, and see, it's gonna show you all the different error codes. We're gonna reset them all. So we're just gonna hold down the button until it disappears. 0, so now there's no error codes in the unit. And we're good. Now I need to see a full call for cooling without tripping the transformer, and we'll be done with this one.
All right, so that one was, another interesting service call, right? This situation was, I was called to help out a location of a particular customer that I don't normally service. I've been doing that a lot lately when we're kind of slow coming through this virus thing, and so I've been able to help people that are usually out of my service area, mainly just because the location is so far from my service area and the traffic is ridiculous, is why we don't service that location. Anyways, they were having a lot of issues with an air conditioning problem. They wanted me to come out and kind of go through it for them. So went out there, and what I found was it was a mess, as usual, right? And I had to put it back into normal factory condition before I could really troubleshoot what was going on. Because, I tried to troubleshoot it with the way that it was, and it was just, I couldn't figure out where the short was. I was picking up, when I initially got there, I was picking up a short, ohming it out, but then it went away and I couldn't find it, and I kept going, and it just disappeared, the short, and it was tripping me out. So then I decided, okay, I'm going to put this unit back to factory spec, put the right transformer in it, fix the couple spots where there might be a short, put that combustion relay back in, and it didn't do it anymore. And the unit started up and ran. I saw all stages of cooling going. It ran for, I think, a day and a half, and then they called me back after that, and they said, hey, it went down again. It's like, oh, okay. I was already anticipating going back with something. What was it? Oh, I wanted to go back and clean it. That's right. But anyways, I ended up going back and found the problem. The problem was the limit switches for the gas heating section, okay? And I showed you in the video that it was that one wire that was just every once in a while shorting out. I didn't see it from the front of the unit. I still don't know why the other company had taken the top off that unit, because there was no refrigeration repairs made to that unit. I don't understand. I don't know. It's sometimes you're never going to make sense of what other people are doing to those units. It was, it's still, that unit looks like crap. But I ended up finding the short. It was in the combustion, or in that little limit switch. I ended up ordering new limit switches, coming back out, putting them in, and the unit is operating. I mentioned this probably in one of my recent videos before this, that I made a lot of recommendations to the customer to have me come in there and PM that equipment, and they declined that right now. I'm not angry. I mean, it's a little bit frustrating because, I don't want that to turn into another emergency service call, but I kind of understand, because we're going through this virus right now. The restaurants still are not open to dine-in seating, so they're not making any money, and they're basically in survival mode. So, they just need to get things patched up and operating so that way they somewhat work. I guarantee that they're going to have me go back in and clean those once they open up the dining rooms. And in fact, the dining rooms are going to be opening here in the next couple weeks to limited capacity, but they're going to start rolling stuff in, and we're going to start getting a lot more service calls at these restaurants. And in fact, most of my restaurants that I go to all have particular pieces of equipment that are broken, and they've just been kind of holding off because they're just trying to save money. They're, again, like everybody else, they're in survival mode. Okay, so they declined the preventative maintenance repairs. They don't want me to clean anything because it's operational, so long as it doesn't become a problem. And like I said, they'll call me back and we'll go back later, okay? But, the whole big picture diagnosis thing that I'm always preaching, guys, all right? You got to look at everything, okay? Even myself, I find myself thinking, I said it in the video, I should have listened to my gut when I first opened up that indoor blower section and I saw on the front limit switch that the ground wire, there was a ground wire. I don't know if you guys can catch it on film, but there was a ground wire that had broken off from the limit switch, and someone had grounded it out. There's nothing wrong with that, okay? It just, the wire itself grounded out. I mean, it had broken off, and I should have dug into that more, but I just saw it and then kept on troubleshooting, And then when I changed the transformer and the combustion relay, or replaced them, and the problem didn't happen again, I was like, okay, I'll follow up. Another thing was that was a Saturday morning call, and it was like, I really didn't want to be there all day. I was already there for a couple hours trying to find a short, and I was a little bit frustrated. Of course, I'm kind of going against my better judgment, because my better judgment is to always give them all of my attention and spend all the time in the world. But it does get kind of frustrating when you get called out on an overtime call and the unit's filthy, the drains are plugged up, all this stuff, and you're like, you know what? They're not going to get all of my attention right now, So I battle with that too. I know I stress to, take care of the customer with the utmost professionalism and stuff, but there's times that you get frustrated too, okay? So I can only give them so much, and, some of my personal time on the weekend, even though I'm on call, they're only going to get so much, and we'll come back when we're not on overtime and follow up and clean it up. That's sometimes my logic, okay? To an extent, I guess I should say. But anyways, we found the problem. It was an electrical short. It was the limit switches, replaced them. It's since been a week. Customers still happy, no complaints. That's pretty much it. Really appreciate you guys taking the time to watch these videos, and we will catch you guys on the next one, okay?